Alright, so now we're talking about the nature of chemical bonds, and we're dealing with electronegativity. Okay, so the electronegativity of an element is the relative measure of the ability for an atom to attract the electrons in a chemical bond. So there's an attraction between the nucleus and the protons of an atom and the valence electrons in the adjacent atom. Okay, so we can imagine the nucleus obviously is going to be positive, where the electrons will be negative, and depending upon which pairing of electrons we have, which pairing of atoms we have, will depend kind of where the electrons are pulled towards. So each element is designated a number to represent how strong its nucleus is at attracting another atom's valence electrons. And where we see this is right here, so right above our elemental symbol, okay? Now, the higher electronegativity means the greater attraction or affinity, okay? So that means that the higher the electronegativity, the more it's going to attract these negative electrons towards it. So the trend on the periodic table for electronegativity decreases down a group and increases across the period. So since noble gases do not readily react with other substances, electronegativity have not been assigned to them. So they do not have any electronegativity. Okay? So understanding how electronegativity has contributed to the knowledge of bonding in ionic and molecular compounds. Okay? That's something that you guys will need to fully understand. So here's electronegativity on the periodic table. This is kind of a three-dimensional depiction of it. And as you can see here, it decreases down the grouping and it increases across the period. And that's something very easily seen there in that 3D depiction. So as you move from left to right across a period, both the electronegativity and the atomic number increase. However, the size of an atom decreases. Okay, so we've got this lovely picture here. And the reason why it decreases is because of the fact that the electronegativity is increasing. It's able to hold its electrons a lot closer to the nucleus of that atom. Okay, so here's why size decreases across a period. The size of an atom depends on the radius of the energy level containing the valence electrons. Okay? In any given period, the valence electrons of each atom occupy the same energy level. Okay? So that's saying that there's the same number of levels of electrons within each given period. Okay? So now as you move across the period, the atomic number increases, and thus the number of protons in the nucleus also increases. So now there is a greater amount of attraction between the nucleus and the electrons when there's more protons. Therefore, the atom is smaller. So again, what I'm saying here is there's more positive charge within the center and the nucleus is to be able to attract these electrons a lot closer to it. Okay? So if we look here at period 2 elements, we've got lithium with 1 valence electrons and 3 protons. Okay? And we're going to compare that to carbon, which has 4 valence electrons, okay, but it's got 6 protons. So it's able to hold it a lot closer. Okay? And we're going to compare that to fluorine, which is 9 protons, and again, it's able to hold that a lot closer. So the next question is, why does electronegativity increase when an atomic size across a period decreases? The reason is the strength of the attraction, and therefore electronegativity between oppositely charged particles depends on 2 factors. It depends on the distance between the charges, so the attractive force between opposite charges decreases with the square of the distance between them, and the magnitude of the charges, so the attractive force is directly proportional to the amount of charge. Okay? We're going to dive a little deeper into that in the next video.